Video problem 98, electrical energy from oxidation reduction reactions. This time we're going to talk about line notation, and so we're going to take a look at this reaction that we did in 97A. Line notation is like shorthand for a voltaic cell, and so what you do is it's always the anode is written first. You do a double line. That double line represents the salt bridge. Alright, and then you do the cathode. Now, within the anode, you do the reactant first, then the product, and if these are in different phases, for instance, let's say the reactant is a solid and the product is aqueous, we do a single line like that to separate the phase. Double line to go to the cathode, and then again in the cathode we do the reactant, then the product. Now, if they're in the same phase, we just do a comma separating them. And then if I need an inert electrode, depending upon what phase this is, let's say it's a different phase, then I would just write the inert electrode. The inert electrode goes at the very end. So over here it would go over here. Okay, on the anode it would go at the very left, on the cathode it goes to the very right. That's if you have an inert electrode. Okay, we have an example with that today. So we're going to use the net ionic equation here, so let me write that down. So here's the net ionic equation, and there it is balanced. Right? So let's think about what's being oxidized and what's being reduced. So zinc is going from 0 to positive 2. So zinc is losing electrons. That means it's being oxidized. So I'm going to do the anode first. I start out with the reactant, which is zinc, solid. No other reactants. Then I write the product, which is zinc 2 plus. It's a different phase. It's aqueous. So I put a straight line. Right? Now, zinc, I can use zinc as the electrode. Okay, so it's on the far left, so I'm good to go. So that's the anode. Now to the cathode. Start out with the reactant, which is the hydrogen ion. Now, a lot of times you'll have to give the molarity of it, so we'll have to say that it's 1 molar or something like that. Right? But we're not going to do that here. Okay. Now this gets into the hydrogen gas as the product. That's a different phase. So that's H2 as a gas. And notice hydrogen ion, hydrogen gas, I don't have a metal there, so I don't have an electrode. So that means I need to have an inert electrode. And I'm going to say that I'm using platinum as a solid for my inert electrode. So there you go. You have the anode. You have the cathode. I can do better than that. Come on. There we go. Okay, reactants first, then products, and then we have the salt bridge right here in the middle.